Okay, graphs of the basic functions look like this. And we should be able to match up the graph with the function. This is your exponential, which is y equals 2 to the x, the basic function that we're using. This is quadratic, y equals x squared, f of x equals x squared. I'm just writing down the formula part. This would be cubic, the x cubed function. This is the square root function. This is a logarithmic function, which is this, and this function's inverse to this one. This is your basic cubic cube root. And it's inverse to the cubic function. The square root function is inverse to one branch of the quadratic function, as we hopefully know. The function I've got here is the reciprocal function. This is a reciprocal square. And this is the absolute value. Now, some of these functions have unique points and some don't. I mean, easily identified unique points. They all have their unique points. Exponential logarithmic functions, we know that they have asymptotes, so we can kind of estimate the asymptote. Or on the logarithmic function, we have this. So I'm going to kind of use red here. I have the chalk in my hand. I don't know why I didn't use it. Asymptotes help you figure out where these graphs are and so forth. Now, obviously, the asymptote would be the x-axis for the basic exponential, and the asymptote would be the y-axis for the basic logarithmic. Okay? Now, for the quadratic function, the vertex. For the cubic function, you wouldn't exactly call this a vertex, but this would be the zero of the basic function. Now, if the cubic graph is somewhere else, then you would know by identifying where that zero should be, at least approximately what the horizontal and vertical shifts would be. The square root, the zero of your basic function is here. Reciprocal square, you have, again, your asymptotes. And for the basic function, those asymptotes would be the x and y axis. Absolute value, this is a zero of your absolute value function. For the 1 over x, again, the asymptotes. For the cube root function, the zero of the basic function. So wherever these graphs are, wherever graph of this shape is on the in the xy plane, you can pretty well identify the asymptotes, the vertical and horizontal asymptotes of the reciprocal and the reciprocal square function. And you know, I wrote this as 1 over square root of x because I was thinking about doing that one. That would be the reciprocal square root. And since the square root is a inverse of the squaring function, I don't include the reciprocal square root as one of the basic functions. It would be regarded as a composite of the square root function and the reciprocal function. So I carelessly wrote a square root sign there. Okay, so if, for example, we have the graph of a quadratic function, then we can easily identify its vertex. Okay, so if the horizontal shift is h, so okay, if the graph is AF of x minus h plus k, in any of these situations, then this would be the point HK. H being the x coordinate, K being the y coordinate of the vertex. Now we would still have to worry about the vertical stretch, and we would get that by estimating the coordinates of another point and then plugging in the values of h and k if we know where the vertex is, and setting this expression equal to the y coordinate and solving for the a. And that's a process that we're pretty familiar with, and people are doing pretty well with it. Okay, so now, in that case, the vertex here, if the thing is in arbitrary position, or some position, some known position in the xy plane, the vertex is the point HK. The zero of your basic cubic, well, that's at the point 0, 0, so if this thing in general, this would be HK. But if it was just the basic function, it would be the 0.00. This point would be HK. The origin of either of these would be HK. Don't have a good place to label that, but I'll do this. And my comma turned into parenthesis, so it's a little sloppy. This would be the point HK. And this would be the point HK. And in these cases, you can only really estimate, and it would have to be an estimate. You might not have a lot of certainty about your estimate, as you kind of would on most of these others. But for an exponential equation, the asymptote would be y equals k. For a logarithmic function, the asymptote would be x equals h. In every case, you would then know or have the, well, in every case but the exponential or logarithmic, you would have the values of h and k, and you could then estimate one other point on the graph and figure out the value of a. Now, of course, we have to understand transformations, but we address that elsewhere.